Okay, so today in class you talked about solving compound inequalities. Well, you talked about the solutions. So what I want you to do is make sure you get the date and the page number, and you get the title and the learning target down. Okay, so let's take a look at this first example. In class, you talked about the difference between an AND statement and an OR statement. An AND statement is shaded in between the two numbers, and an OR statement is shaded on the outside because an AND statement includes both things. So let's talk a little bit about what this is. So this is one that has to be solved. So before I can get started, I need to figure out, well, what is M in between? So this time, because it's an AND statement, because it has to satisfy both of these things, I have to solve it as one. So what I'm going to do is I'm getting M by itself. So just like I would if I was ignoring this, and I need to get M by itself, and I need to move the minus 4 away from M, I would add 4 to both sides. But instead of having 2 sides, I have 3 sides this time. So I'm still trying to get M by itself, but I'm trying to get it in the middle. So I've got to move that minus 4 from the middle to all of my sides. And when I do that, I get 1 M and 3. And I didn't do anything. I didn't multiply or divide by a negative to have to flip those signs around. So right now it says M is bigger than or equal to 1, but it's also smaller than 3. So because this is in the middle, it's an AND statement, which means it needs to satisfy both of these things. So let's start with just this thing. M is bigger than or equal to 1. It would be a closed circle at 1, and it would be this way. 3. M is less than 3. That's what this says. M is less than 3. So it would be an open circle at 3, and everything's smaller than that. So this part right here in the middle is the part that's shaded by both inequalities. Therefore, this is my answer represented as a graph. This is the answer. And then if I wanted to write an interval notation, which you practiced today, then I would put the lowest number first, which is 1. So it goes from 1 to 3. It can be 1 because it's a closed circle, so I'm going to use a bracket. It cannot be 3, so I'm going to use a parenthesis. That's why it's an open circle. So this says all answers from 1 to 3, including 1. This is what the graph says as well. And then this is the answer you got when you solved it. Let's do one more example, but this example is going to be of an OR statement. So remember, OR is 2 separate things. One doesn't affect the other. So I'm going to solve it like it's 2 completely different inequalities, because they are. They don't depend on the other one. So I'm going to solve this one first. Okay? Can't distribute, can't combine like terms. All my t's are on the same side. So I'm going to move plus 2 to the other side. So I need to subtract 2, bring down the 3t. Negative 7 minus 2 gets more negative. And I didn't do anything to flip this, so it stays the same. Divide both sides by 3. Divide this side by 3. T is less than negative 3. Notice I didn't flip this sign because what I divided by was a positive number. Okay, so then I can go ahead and graph this because, like I said, this second inequality, doesn't have any effect on this one. So I'm going to put an open circle at 3, and I'm going to shade everything this way because t is less than negative 3. So now I'm going to put a box around this one because I'm going to solve it completely separately. Completely separate. Alright, so I need to get negative 4t by itself because I can't distribute, I can't combine like terms. All my t's are on the same side, so I'm going to box this, move plus 5 to the other side. So I'm going to subtract 5, and I get negative 4t is less than negative 4. I didn't do anything to flip this sign, so it stays the same. Divide both sides by negative 4. And t, 1, this time I flip it. Negative 4 divided by negative 4 is 1, but see how I divided by negative 4 here? Then I need to flip this sign. So t is bigger than 1, so it should be an open circle at 1 and going this way. Now you graph these today and you put them in interval notation, so this part here should just be a review. The solving part should be the new part. Alright, so if I was going to write this in interval notation, then let's talk about what the solution is. It goes left forever, which is negative infinity, and it goes all the way up to negative 3 and stops. It's an open circle, so I'm going to use a bracket. There's a gap here. I can't just say it goes from negative infinity to positive infinity. There's this open part. So to show that, I have to show that it stops at negative 3, but it picks back up again at 1 with an open circle, so it's a parenthesis, and then it goes from positive 1 to positive infinity. So that's my answer in interval notation. I can't just say negative infinity to positive infinity, because that would mean it's everything, including what's in between here, which is not true. Alright, so that is it for tonight. Make sure you added these things in your table of contents and you answer the question at the end.